A whale skeleton beneath a desert, wild pigs tamed by ancient Indian farmers, rogue tigers identified by their DNA, and nanoparticles that keep human blood flowing. This is This Week in India's Science. I am Shubhra Priyadarshini. Kutch, Western India, in the parched bed of a seasonal stream called the Khari River. Something ancient waits beneath layers of sediment. A small team of paleontologists fans out looking at the sun-baked earth for delicate clues. They are searching for microfossils, shells of tiny marine snails that once thrived in this long-lost sea. But then something unexpected emerges from the ground. The team of paleontologists has uncovered not a snail. It is far larger, vertebrae, ribs, and scattered remnants of a small whale, preserved in stone for nearly 20 million years. This is one of India's first fossil whale falls, a glimpse into a dramatic moment that still plays out in the oceans today. When whales die, their bodies sink, becoming oases on the seafloor. Scavengers gather crabs, worms, and strange creatures like osedacs, bone-eating zombie worms that drill into the marrow. Using CT scans, Preetha Goswami from the Indian Institute of Technology, Roorkee, and her team found distinctive bore holes in the fossilized bones, evidence of osedacs-like activity.
This study sheds light on past ocean ecosystems and how animals adapted to the resources provided by the dead whales in the deep sea during the Miocene.
Long ago, these seas covered much of Western India, and even as continents shifted, life adapted. This discovery, reported in Nature India, offers a rare window into the rich Miocene seas of the Indian subcontinent. Have a read. Now, a quiet genetic revolution has been unfolding of pig domestication.
What we found was that the Indian domestic lineage, it came exclusively from a special wild boar branch. It showed no signs of migration or connection to the European branch or any other domesticated branch in the world. And this confirmed our hypothesis of domestication within India.
For decades, the dominant theory held that pigs arrived in South Asia from other domesticated centers. But this new genetic work, led by Gyaneshwar Chaubey and colleagues, paints a different picture. Early farming communities here, it seems, were not just passive adopters of livestock from elsewhere, they were shaping wild boars into domestic pigs on their own. Evidence of this intimate relationship goes beyond genetics. In the tribal art of central India, pigs appear in ancient rock paintings, their curved backs and snouts etched in ochre and charcoal. Pig bones, ground into fine powder, were used for tattoo pigments, woven into rituals of birth, adulthood, and healing. India has 14 registered breeds, many of them understudied. There's still much to learn about this history. This surprising new view of pig domestication was featured this week in Nature India. From ancient domestication to modern conservation, India's wild places continue to demand new ways of thinking. In Madhya Pradesh, where tiger reserves abut farming villages, conflict simmers. Tigers occasionally stray into human settlements, livestock is killed, and the villagers, anxious and afraid, call for action. For years, national park authorities have struggled with a very basic question: which tiger is responsible?
Knowing which animal is responsible for a kill is essential. Without precise identification, we risk removing the wrong animal, which can worsen conflicts, disrupt local ecosystem dynamics, and erode public trust in science.
Himanshu Chattani from the Wildlife Institute of India. Over 4 years, Chattani and his colleagues traced genetic markers from nearly 90 tigers involved in livestock predation. The pattern surprised them. Sometimes relocation or removal is necessary, but precision in these things matters. One wrong move can destabilize tiger social structure, sometimes increasing attacks rather than reducing them. Even more remarkably, the team is now testing portable handheld sequencers, field ready devices capable of reading tiger DNA at remote kill sites within hours. The goal is rapid field sequencing, a full genetic ID done on site by moderately trained personnel. This cutting edge conservation strategy was detailed in Nature India this week. Biomedical engineers at the Indian Institute of Technology, BHU Varanasi, have developed complex nanoparticles that can prevent blood clotting, not only in lab models but in living animals. For people with thrombotic disorders, these nanoparticles could be a safer and more efficient alternative to existing anticoagulants that cause bleeding and bone damage. Made from ferric sulfate, potassium oxalate, and stabilizing agents, the nanoparticles bind calcium ions, halting clot formation by blocking fibrin proteins. In live mice, the particles prevented clotting without damaging organs or deforming cells, even at low doses. Human blood samples treated with the particles remained fluid for 48 hours, opening possibilities for safer storage and transfusions. They dissolve easily in water, they don't accumulate in fat, they move swiftly through blood vessels, coating medical catheters with a slick surface that resists protein buildup. These tiny particles could offer a powerful new option for patients at risk of stroke, heart attack, or dangerous clots. And this was reported this week in Nature India. From ancient bones beneath a dry riverbed to ancient farms reshaping wild animals, to wild tigers navigating fragile boundaries and the precision manipulation of human blood itself. This has been This Week in India's Science. I'm Shubhra Priyadarshini. Join me with the latest from the world of science in India next week.